Welcome to all in this our YouTube channel. Now we have already seen some colloidal properties of solutions, that is lowering of vapor pressure and elevation in boiling point. That 2 points we have already covered in our last video. But in continuation with that colloidal properties, this is our third colloidal property, that is depression in freezing point. Now what is meant by freezing point? First of all we will see, then we will go for its depression. Now the freezing point of any solution or liquid is the temperature at which the vapor pressure of liquid becomes equal to the vapor pressure of solid. That temperature we are calling it as a freezing point of that corresponding liquid. Now here there are some terms which I have denoted here, that is delta 0F and T0F and TF. As early in elevation in boiling point we have seen T0B and TB. Like that the same terms are also we have taken here. But for better understanding we will take how these two terms are related with each other. Let us consider a simple example. For example, if you have a liquid and in that liquid if you have added some amount of salt, that is a solute, in the form of solute we have added, then at that time here T0F is the freezing point of pure solvent, we can say, and TF is the freezing point of solution. In that case, for pure solvent, the freezing point always greater than that of the solution. Why it happens? Because the freezing point of pure solvent is always has more value than that of the solution because of addition of solute particles in it. So, for better understanding, we are plotting this graph, that is, here we already said for pure quantity, that is for pure solvent, its freezing point is always more. Due to the addition of solute in it, the freezing point of solution becomes lower. Therefore, for getting positive value, we are subtracting the freezing point of solution through the freezing point of pure solvent, because its value is always more. Now here look at this graph. Here we have plotted a vapor pressure curve against temperature. Now here we are getting three curves. Look at here, the curve AB, curve CD and curve EF. What it indicates? The first curve is nothing but the for solid solvent, and the second curve CD is for liquid solvent, and the curve EF, this curve is for solution. Now when we consider the curve AB and CD, these two curves meet in the single point. That point we are calling it as a point B. Now this point B, what it tells us here, when the two curves are intersect in point B, means solid solvent is in equilibrium with liquid solvent. So this is the very important point you just take into account. And again this point, from this point B, if we plot two dotted lines for vapor pressure and for temperature, we get 2 points here. If we plot a dotted line on y-axis parallel to this x-axis, then we are getting P0, and this P0, what it indicates? It is nothing but the vapor pressure of pure solvent. And if I plot dotted line parallel to the y-axis on x-axis, then we are getting this value, that is T0F. And this T0F is nothing but what? Freezing point of pure solvent. Okay. From the plot we have determined the freezing point of pure solvent, and here another point now we are going to explain. This curve AB, if you look at this curve AB and curve EF, these two curves meet in a single common point. That point we are calling it as a point E. And if I did the same thing again, I have plotted dotted line on y-axis and on x-axis. Then on y-axis I will get this point. At this point we are calling it as a P. This P is nothing but the vapor pressure of solution. And if I plot on x-axis at this point, I am getting TF. That TF is nothing but what? Freezing point of solution. So this is the very important criteria. And here always what we are doing for getting positive value, we are subtracting the bigger value, that is less value from the bigger quantity, so as we are getting the positive value of delta TF. That is, depression in freezing point is nothing but the difference between freezing point of pure solvent minus freezing point of solution. So this is the equation that by this equation we can say that we can determine the depression in freezing point. Depression is nothing but what we can say, it is lowering. Instead of depression, for your better understanding you can take its meaning as a lowering. Okay. Now what is the use of this depression in freezing point? In cold countries, for removing the salt which is collected on the roads, by spraying some salt, that solid ice can be removed. That is the important use of this depression in freezing point. Okay. So in continuation with that use, we are looking forward for its equation. What is the relation between depression in freezing point and molarity? It is directly proportional to it. Why? I already explained in my last video. Directly proportional to the molarity. Why? Because the number of moles of solute particles are very important here. As number of moles of solute particles increases, depression in freezing point also increases. So this is the important case. That's why we have taken here directly proportional. Now instead of this proportionality sign, here we can take the Kf, that is Kf is nothing but the proportionality constant. Here Kf we are calling it as a freezing depression constant, that is freezing point depression constant, or it is also termed as a cryoscopic constant. Now if you want to determine the units of K, then what we have to do? We have to modify this equation in terms of Kf. Now that we have did here, Kf is equal to delta Tf upon m. Now delta Tf we are measuring in terms of Kelvin, because this is nothing but the simplest temperature, and that we are measuring in terms of Kelvin. That's why I have used K here, and m is the molarity, and we are measuring that in terms of kg per mole. So the unit of Kf becomes Kelvin kg per mole. Now this is about what we can say depression in freezing point. Now we are moving to the next point, that is relationship between depression in freezing point delta Tf and molar mass of the solute, that is M2. Now this derivation can be asked in your exam for 2 marks in your theory question, and on this relation you will get number of numerical, that is after the chapter you just go on solving. After we are getting the relation between molar mass of solute and depression in freezing point. By the use of that formula you can solve n number of examples, that is numericals. Now to show this relation, what we did, we prepared a solution by dissolving W2 gram of solute in W1 gram of solvent. This is a very important thing. First of all, what you have to do, you have to prepare a solution by dissolving W2 gram of solute in W1 gram of solvent. Then what we can say, the number of moles of solute in W1 gram of solvent means the number of moles of solute are important here, and that we can determine with the help of this equation. That is, N2 is nothing but number of moles of solute are nothing but the weight of that given solute particles divided by the molar mass of that solute we have taken. Okay, so N2, it means that this equation. Okay, now we will come to the definition of molarity. Now what is meant by molarity of the solution is nothing but the number of moles of solute particles when dissolved in a kg of solvent. That is, weight we are measuring in terms of kg. This is the definition of what we can say molarity. And when we came across its equation we will get like this: W2 divided by M2 into W1. This W2 M2 is nothing but what we can say here N2. Instead of N2 we are using these two terms, that is W2 divided by M2. So here this equation becomes W2 divided by M2 into W1, that is W1 gram of solvent. Now we are substituting this value of M in equation 1. As we have already written here the equation 1, to show the relationship between depression in freezing point, that is delta TF and the delta TF and the molar mass of the solute. So for that purpose you have to use this equation, and this value we have substituted in this equation 1. So we will get this equation. So what we did here, look at delta TF I have kept as it is, and here KF also I have kept as it is. Instead of this molarity term we have substituted this value here, and on simplification we will get this equation, that is M2 is equal to Kf into W2 divided by delta TF into W1. This equation is, if we want to solve the numerical and all the values you have provided in terms of MKS unit or SI unit, then you should use this equation, that is this one. And if all the terms which they have given at that time, that is at the time of solving the numerical, then you should use this equation, that is M2 is equal to Kf into W2 divided by delta TF into W1 multiplied by 1000. For the conversion of these two equations, you can also use by your choice. That is, if they ask your answer in kg per mole, then you should use this equation, and for gram per mole you can use this equation. So this is the relationship between what we can say molar mass of solute and that is depression in freezing point, that is delta TF. So number of numericals are also there on this equation. You just go on solving, and for better understanding you can also review this video, and you just go on solving the numericals which you will get on this final equation for your better preparation. Okay, thank you very much.